Project background and information. The project development is actually a double-story house with a site area of 35,000 meters square. Type of the development is a terrace house and the total number of house is 46 houses and each house is 1,400 meters square. Company name is Perbadanan Kemajuan Tanah and Adat Melaka and the address is at number 1-1 Aras 1 Jalan Dr. Wan, Taman Delima Raya, 75,150 Bukit Baru, Melaka. The project name is proposed in design, construct and complete the medium cost of double-story terrace house and other design and build work part of plot PT 336 Mukim Semabuk Central, Melaka, District Melaka. Team working and organisation. Team working of this project consists of 5 main leader design all of the project, which is project manager, senior project engineer, QC engineer, QA engineer and QS engineer, as you can see in the left figure. The objective of this project are first, to ensure and develop technical knowledge on design process in field of construction works among the students. Next, to identify the capability to implement sustainability on design and construction stage to environmental friendly. Then, it is to justify the practice of current software to design the actual building structures. And it is also to organize the project management to deliver the most cost effective.
Assalamualaikum, my name is MUHAMAD dari LOKMAN, number matric CN180160. I would like to present about the project. So my part is the infrastructure parts. So firstly is the earthwork layout. So in this earthwork layout, we propose the temporary level, platform level, road level, and we propose the temporary drain, washing bay and others. So next is the earthwork calculation. The calculation is the cut and fill to know the volume of cut and fill in this construction area. Road and drainage. So in the road drainage layout, we propose the box covered road and the drainage. So next is the road and drainage calculation. So the calculation is the invert level of the permanent drain. This is all the drain invert level that we calculate. Water reticulation. In water reticulation plan, we propose the sluice valve, washout, fire hydrant, and bulb meter for this plan. Next is the water reticulation calculation for the pressure loss in pipeline. These are the calculation for that. So next is the sewerage. This is the sewerage plan that we propose the manhole pipe in this project. So next is the sewerage calculation. This is the calculation, population, equivalent and invert level of sewer pipeline calculation. That's all the manhole that we calculate. Thank you.
Method statement. As for infrastructure work, there are a few method statements were found to ensure the correct procedures of the activity work need to be done. The first figure on the left side shows the construction sequence of culvert and surface drainage activities, and the second figure on the right side shows the construction sequence of concrete road curb. Both of the figure is actually a part of road and drainage construction work activities. Next, the first figure on the left side shows the construction sequence of installation the main pipe, and the second figure on the right side shows the construction sequence of backfilling of pipe, trench and compaction. Both of the figure is actually a part of the water reticulations construction works activities.
Conclusion. For conclusion, this project able to develop technical knowledge on design process in field of construction work, either in infrastructure or structure building. It is also able to show the capability to implement sustainability on design and construction stage toward environmental friendly. Lean and practice to design the actual building infrastructure by using software were the outcome of this project. This project also required to organize the project management to deliver the most cost-effective according to relevant standards.
For structure part, there are 5 content, which is the manual calculation for beam and slab design, the discussion for the assumption made, the method statement for structure work, and conclusion. For design documentation for structure work involve the manual calculation of beam and slab. For beam, it consists of continuous and simply supported beam. For slab, it consists of one-way and two-way slab. For continuous beam, we have chosen the beam 1B of B to J. The figure shown is our selected continuous beam. For calculation, we started off with the characteristic of permanent and variable action. On beam 1B, B to J, the weight of concrete is 25 kN per cubic meter. The finishes, ceiling and services is 2 kN per square meter. The variable action for all slab is 3 kN per square meter. The beam size is 230 mm times 500 mm. The slab thickness is 125 mm. Then we start to calculate the action on slab, distribution of action from slab, then action on beam. The action of beam includes 3 span, which is span BE, EG, and GJ. After obtaining the total permanent and total variable action, we establish this diagram. The calculation of the design start off with the listing of the specification, materials, and assumption of diameter of bawan, batu, and link. Then we move on to the durability, fire, and requirement. After that, to loading and analysis. Here we can obtain the design action, maximum shear force, and maximum bending moment. Then we use the moment distribution method for elastic analysis of the beam. In this method, we can obtain the shear force and bending moment envelope of beam 1B of B to J. First, we obtain the loading, then stiffness and distribution factor of each span. Then we obtain the fix and moment. After that, we do the moment distribution table, and from there we can find the support reaction for every span involved. Then we calculate the bending moment diagram using the formula 1/2 times height and times length. Based on the area tension of steel result, the suitable size of bar assumed is 10H40 in 12,568 mm². Then we proceed to the checking for cracking and spacing. If the spacing of outer bars is less than the maximum spacing, then the assumed size and numbers of bar are acceptable. Then we proceed to the deflection. If the maximum span is bigger than the actual span, then the design is okay. Next is the flexural support. If the K is less than K bar, then compression reinforcement is not required. Then we can obtain the shear force diagram and the bending moment diagram. After that, we move into the main reinforcement of flexural design. First, we find the effective depth, then the flexure in span. If the K is greater than K bar, it means the compression reinforcement is required. Then we calculate the area of tension reinforcement and the area tension of steel. Here, the assumed 4H20 in 1,257 m² are acceptable as the spacing of outer bars is less than maximum spacing. Next is the shear in reinforcement, where all the support from support B, E, G, and J has their shear inspection. Next is the detailing checks, where the minimum area and the curtailment of main bars are calculated. The figure shown is the established reinforcement details.
For simply supported beam, we have chosen the beam 1-1BF. The figure shows our selected simply supported beam. For calculation of the simply supported beam, the permanent value is 2.57 kN/mm². The variable value is 3.0 kN/mm². Unit weight of concrete is 225 kN/mm². The beam size is 100 times 250 mm². Then we calculate the reaction on beam. Here we get the maximum shear force and maximum bending moment. For the main reinforcement, we calculate the design bending moment, and since K is bigger than K bar, so the compression reinforcement is required. Then we calculate the area of tension reinforcement, area of compression steel, and area of tension steel. Based on the area tension of steel result, the suitable size of bar assumed is 2H20, which is 628 mm squared. Then we calculate the shear reinforcement, shear link, and shear resistance of minimum link, so we get the link arrangement as shown on the diagram. Then we calculate the additional tensile and the additional longitude reinforcement. Then we proceed to the deflection and cracking. The detailing, the figure shown is the established reinforcement detail.
Calculation for slab. Okay, this is the example of two-way calculation slab. Okay, for two-way slab, we use first floor slab 3, and one-way slab is first floor slab 2. For both calculation, one-way slab and two-way slab, we use European standard, which is Euro Code 2. The assumption for diameter bar is 8 mm, and the assumption for design life is 50 years. The fire resistance is R120, which according to table 5.8 in Eurocode. The thickness in the calculation for two-way slab is 180 mm. The thickness of the slab, which can determine by fire resistance requirement and deflect control, which most common thickness limitation. All the assumptions were made due to economic factor and good design of structure.
On June 17th, our group interviewed Encik Mio Nazif bin Mio Zahari, who is the site engineer from MTC Imperial Sdn Bhd with his colleague Muhammad Yazid bin Jamil, who is the draftsman. We decided to interview them since their experience in engineering fields has grown, and we believe that they will have a unique viewpoint on issues resolution on the construction site. The interview session was organized by using Google Meet and has been performed in 1 hour. Problem and solving. The first one is slope collapse problem. When heavy rain falls, this cutting and filling process might cause soil flow into surrounding waterways. So, to overcome this problem is slope stabilization work must be done in accordance with the regulation, and protection on the slope must be made to prevent surface erosion and water infiltration into the soil. Additionally, constant monitoring of the slope construction is required so that any hazard change will be discovered quickly. The contractor should undertake high rec to identify possible risks that may occur in the region surrounding the slope cutting as a control strategy. Second is polluted roads. The most common issue is that truck wheels which are not washed while leaving construction site that have been under construction cause the road to become polluted with wet soil effect. To overcome this problem, construction site must provide a wash bay to keep it functioning optimally and efficiently. To mechanic also prevent the public road from any pollution.
You have to you have to do some kind of sloping lah in order to make the overburden or the soil to be stable lah.